Let's compute the divergence of a vector field. In this particular case, we have the vector field f. First coordinate function is the natural log of 3x squared plus 6y squared. The second coordinate function is 18xy. And the third coordinate function is the natural log of 6y squared plus 3z squared. And normally we will use these letters for the coordinate functions m, n, and p. Now the divergence is something that you use in Gauss's theorem, which is a vector calculus theorem, so we need to be familiar with it. Now the definition of divergence is just the nabla operator dotted with f, and the nabla operator is just the vector of partial derivatives. That is the partial with respect to x, y, and z. And when we dot it with the vector field, we just get what we normally would appreciate in this type of computation. We get the partial of m with respect to x plus the partial of n with respect to y plus the partial of p with respect to z. So it's a very simple computation to remember. And so now we just simply substitute the coordinate functions here into the definition. So we have the x partial of the natural log of 3x squared plus 6y squared plus the y partial of 18xy plus the z partial of the natural log of 6y squared plus 3z squared. Now, using our knowledge from Calculus 1, we reciprocate, then multiply by the derivative with respect to x, which is 6x, and then of course here we just get the partial with respect to y, which is 18x, and here we get the partial with respect to z, so we reciprocate the argument and then multiply by the derivative of the argument with respect to z, which is 6z. And so if you push everything together, we get 6 over 3x squared plus 6y squared plus 18x plus 6z divided by 6y squared plus 3z squared. Now, of course, you can always evaluate these at points in the domain. And so if we computed the divergence at 1, 1, 2, which as an engineer and physicist you would be interested in doing, we simply replace the x with 1, the y with 1, and the z with 2. And as you look here, this will give us a 6, a 3, plus a 6 downstairs. Here we get an 18. And here we get a 6 times 2, 12, of course a 6, and then a 3 times a 4, which is 12. These two reduce to 2/3 very easily, and if we write 18 as 54 over 3, we get 58 over 3. And we are done.